Hello everybody, welcome to our webinar. I'm Lőrinc Daróczi and I'm excited to share with you the details about the new features of the Simon system to provide a comprehensive solution for spectrum monitoring and management at events and high security sites. These new features are still under development and will be available in production in the second quarter of the next year. With the development of the Simon system, we created a solution which allows our customers the ability to create a radio monitoring network with fully equipped stations, compact monitoring stations, and also mobile stations. This year, we started the development of new features which allows our customers the ability to deploy a multi-station monitoring network with portable, compact monitoring devices for monitoring special events like the Formula One race or concerts, music festivals, or high security sites. These are some pictures of portable compact monitoring stations. On the left is an example of a compact station with omnidirectional antennas. On the right is an example of a compact station with built-in antenna rotator to also support directional antennas. Of course, these compact stations can also be equipped with direction finder antennas. To better understand their new functionality, I would like to share with you an overview of the architecture of our system. The devices on a typical measurement station are controlled by the Simon service, which is deployed to a local PC. The Simon service integrates the device drivers, which control over a local network the antenna switch and the rotator, the monitoring receivers, and the direction finder equipment. The measurement stations controlled by the local Simon service are integrated to the Simon central server, the central service, which provides central access to the measurement capabilities of all stations. The users usually log in to the Simon Central and execute measurements on all the integrated measurement stations, but they also have the option to connect directly to a measurement station and use all local measurement capabilities. This option is typically used with manned or mobile monitoring stations. This year, we re-architected our system to support the deployment of a portable multi-station monitoring network for monitoring events and high-security locations. In this case, our software is deployed on a high-performance server in a control center. The control center can be a mobile measurement unit in a van or a truck. The Simon server runs the central service and also several Simon services, each responsible for the management of a portable station or a measurement location. These portable stations can be simple stations with monitoring receivers and omnidirectional antennas, or stations with antenna rotators and directional antennas, or even stations with a direction finder. This is the current list of devices which are integrated in the Simon system, and we support the use of these devices with this new functionality. Basically, we support integrated devices from multiple vendors like Narda, Rode Schwarz, IZT, ComSaudit, CRFS, Aritsu. The list mentions only the devices which we have integrated, tested, and is in use by at least one of our customers. To demonstrate the new event or high security sites monitoring capabilities, I will switch to the browser. For demo purposes, we have created a virtual site monitoring network around the Hungarian Formula One racecourse. Of course, the deployment site can be any location, for example, high security sites like an airport or the sites of music festivals or other sporting events. Usually for events, the authorities grant temporary frequency use licenses, and the goal of deploying a portable monitoring network is the ability to monitor the use of the temporary licenses to prevent interferences and to detect unauthorized transmissions. We have developed a new direct measurement interface, which allows simultaneous measurement with multiple stations. The user selects a master measurement station, selects the desired antenna and the measurement equipment, and starts a multi-site measurement. The new measurement interface shows all measurement stations with the same configuration so that the user can involve additional stations in the measurement. The maximum number of measurement stations which can be used is configurable. The maximum number depends on the performance of the server running the Simon background services, the CPU and GPU performance of the client PC or laptop running the browser. With multi-site measurements, you have to consider also the network throughput between the stations, the central server, and the client PC. If I select a station with a directional antenna, of course, I have also the ability to control the antenna rotator. Basically, I can control the polarity of the antenna and also the direction of the antenna. So, for example, I can rotate the antenna to a vertical position, or I can rotate the antenna to a given location, to point to a given location. Basically, this control allows per each station the rotation and the control of the antenna rotators of the stations. Usually, during the measurements, most of the measurements are executed with omnidirectional antennas to get a better overview of the spectrum. So if I go back to the main user interface, I select omnidirectional antenna. I start a multi-site measurement. The master site is loaded, and on the map, as I mentioned, we display all the measurement stations which have compatible devices. So I can select multiple devices, multiple stations on the map, and in the user interface, the station list will contain all the stations which can be used. They have a compatible receiver. Basically, when I select multiple stations on the top of the screen, when I configure the measurement settings, I can configure the measurement settings for all the stations simultaneously. So, for example, if I want to execute a measurement in the FM band, I can set the center frequency and basically start a new measurement. If I'm done with the map, I can hide the map so that the user can concentrate on the spectrum. Of course, I can zoom in on the spectrum. I can see all the details, and of course, as you can see on the top in the spectrum analyzer, we can display the spectrum data for all the selected stations. The colors for the stations are also displayed down here, and of course we can hide some spectrum data for some of the stations. I can individually control which spectrums should be displayed. And of course, I can switch the waterfall diagram between the different stations. When I click on the waterfall diagram, the active stations waterfall diagram is shown. So if I'm interested in viewing the channel power of some frequencies, I can create frequency markers, I can configure the bandwidth of the frequency markers, and automatically the system calculates the channel powers of the selected markers. I can have multiple frequency markers, and I can configure them by drag and drop, or I have also access to the property panels of these frequency markers, and I can configure the bandwidths manually to exact specifications. Of course, besides the typical frequency markers, I have also the capability of creating additional types of markers. So, for example, I can create level markers to mark some levels, or additional level markers, or if I'm interested, I can also create time markers and time difference markers. So these informations and these markers are displayed also on the timeline view, and also on the waterfall diagram. Of course, basically the ability to view the frequencies is also controlled, and I can get an overview of which frequency band am I using. I can zoom the screen to fit all the frequencies. And of course, the typical measurement scenario is not just monitoring one frequency band, but browsing the frequency range of the system. So by dragging the spectrum diagram, I can switch to different frequency ranges, and I can browse and I can see what frequency use is in different frequency ranges. So, for example, in the case of an airport, I can look and see the communication bands used by airports. And I have also the capability, also in these cases, to zoom in, zoom out, and of course change the display of the system. Of course, anytime I can switch to a different waterfall diagram, I can switch back to the master's waterfall diagram, and I have also the ability to display and to calculate if it's interesting the maximum of all the frequencies, the maximum levels, so that I can see in a long time period what frequencies were and are in use. If I'm interested, I can look also on anomalies. I can stop the measurement anytime. Of course, I can create also area markers if I want to draw attention to some interesting details. And of course, I can configure the system so that I can access the most information from the spectrum data. If I'm not interested in the time chart, I can hide it. I can hide and redisplay the color scale, but I can maximize the screen or resize the screen to display only the relevant data for my system. Of course, anytime if I want to configure the exact settings for the different markers, I can use the marker property panel to configure the exact frequencies and areas of the system. I can restart anytime the measurement, and of course, as I mentioned, I can switch anytime between the different waterfall diagrams of the different stations. Of course, for demo purposes, if I switch back to the FM range, I can configure the color scale, or I can adjust automatically the color scheme if I'm interested, I can simply remove some markers. But what is important, if I want to configure and listen to one of the measurement stations, I can one of the transmitters, I can set this as a center frequency, and I can access the advanced panel and configure so that the demodulation of the selected frequency, so that I can listen in on the audio. Of course, here on the stations panel, we have access to all the configuration of the station, all the configuration of the measurement equipment, and some settings I can configure individually for each of the stations. We can configure all the stations so that they use the master station settings. Or if I unlock the stations, I can configure some of the stations individually. So, for example, if I want to change the detector of one of the stations, I can use this setting. So the station is unlocked and it's not it is a different set. It can use a different settings with each of the stations. I can, of course, relock the stations so that the master settings are in use. Basically, the configuration of the stations so that we can display all the measurements in the same display waterfall diagram. They have to be compatible so that they have to have the same EF panorama and the same resolution. But some settings can be configured individually for each of the stations. So usually using this configuration, the user can get an overview, and as I mentioned, the user can zoom in and see all the real-time bandwidth of the system. But of course, the user can zoom in and can change the center frequency so that we can browse all the different frequency bands. Of course, as I mentioned, if we have the capability of and the possibility of creating temporary licenses, it depends on where we grant these temporary licenses. We have the possibility of displaying these types of licenses, and we can see if there are some licenses, or we can also display them in a grid view, or even we can display them so that the user can see where there should be some information or some transmitters. If I'm interested in details, for example, if I go back to the FM range, I can see all the stations, the station names, and the information regarding the selected station. So this type of overview, the user can see and get an overview of the licenses which are registered. He can compare them with the measurements on our stations. As I mentioned, we can switch between the different waterfall diagrams so that the user can see the usage, the channel usage for each of the stations. And of course, if we detect some unauthorized transmitters, the user has the capability of sending manual measurement units to the given location to detect the interference or the unauthorized transmitters. Currently, this multi-station measurement supports this window supports peak frequency measurements with browsing capabilities. But during the development, we also plan to implement direction finding and geolocation capabilities. So we plan to integrate also the capability of executing direction finding measurements. If the measurement stations which are selected, they have direction finding antennas, we will also implement the capability of geolocation. Currently, we support angle of arrival geolocation, but we are working on also implementing TDOA-based geolocation, so that we can perform geolocation with simple, more cost-effective, portable measurement equipment. These are the features which we have implemented as of now, but we plan to extend the multi-station measurement capabilities with further functions and capabilities. If you miss some features or have different use cases related to these new features, please feel free to share them in the comments or send them by email. We are open to suggestions to make our solution more comprehensive. If you have any questions, please feel free to ask. We will try to answer them at the end of the webinar, or if we don't have time, we will reply and send the replies by mails to our registered users. Thank you for your attention.
Welcome to our presentation on Simon International, our cutting-edge spectrum monitoring software designed to support your daily operations. I'm Gergő Rója, and now I will talk a little about what were the driving forces to create the system, what are our foundations, and how we envision future. Combit was founded 27 years ago as a custom software development company. We are the member of Grafton Group, so group-wise, we are disposing of around 150 developers, which provide us a very stable delivery capacity. We work with Oracle relational databases since the early 2000s. We are running MySQL Cloud Service implementation projects in the Central Eastern European region, and all the other numbers that are listed here are rising on daily basis. We started to work with the Hungarian Communications Authority in 2004. So for today, we have 20 years of experience in this business. And when I say we, please do consider all those highly qualified professionals who are responsible for the coding, the testing, and also those who added the professional background from the monitoring department side. The name of the software that Combit developed is Simon, referring to the word spectrum and interference monitoring. The present version is the third iteration already. It had gone through a full rebuilding based on user journey methods. From the first day, our intention was to change and improve the daily life of our users. The goal was to create a system which is effortless to handle, logical, structured, and most importantly, visually architectured, meaning that we put the map into the focus of all activities. And beyond these, you are going to be able to manage all the pieces of equipment you use from one common interface. One of Simon International's key strengths is its vendor-independent architecture. We understand that in the rapidly evolving field of technology, regulators need the flexibility to choose the best available measurement devices without being locked into a single vendor's ecosystem. Our system seamlessly integrates with a wide array of monitoring receivers, direction finders, and control equipment from leading manufacturers like Narda Signal Shards, Rode Schwarz, or Anritsu, for example. And the list you can see here is continuously growing. Our developer background gives us the opportunity to integrate any other devices which you already have or plan to integrate into your system. We can integrate spectrum monitoring equipment like receivers, direction finders, control devices like antenna switches, rotators, GPS devices, or even weather station equipments. This multi-vendor compatibility ensures that you can always use the most suitable equipment for your specific monitoring task. Whether you are working with fixed stations, mobile units, or temporary deployments, or even drones, Simon International adapts to your hardware choices. As the speed of innovation increases, so do the expectations for impacts. This results a significantly shorter equipment lifecycle. New and innovative devices continue to emerge, addressing a wider range of use cases and solving long-standing operational issues. Artificial intelligence serves as a prime example of this trend. The good news is that our Open Driver Development API allows for the integration of any equipment, provided there is a proper documentation. This means that as new devices enter the market or as your needs evolve, Simon International can easily accommodate these changes without requiring a complete system overhaul. At Combit, we take immense pride in our ability to remain agile and centered around our customers' needs. Our dedicated team of experienced developers works hand in hand with regulatory bodies to create and implement tailored features and enhancements that meet specific demands. In our journey, we have observed that while there are common challenges in the spectrum monitoring landscape, each regulator and engineer around the globe faces their unique set of hurdles. Thus, it is unrealistic to expect a robust closed system to offer the same level of user experience that individuals rightfully anticipate in 2024, without necessary customization. This is precisely why we emphasize the importance of flexibility as we progress. Our commitment to continuous system upgrades and development reflects our dedication to serving our clients. Each new feature is not merely a product of our own vision, but rather a direct response to our customers' requests, rigorously validated through real-world operational experiences. To facilitate this, we have established a comprehensive maintenance service that automatically provides all our clients with the latest upgrades. We believe this initiative is crucial for fostering a professional community where spectrum monitoring experts can actively shape the trajectory of advancements, concentrate on pertinent issues, share insights, and collaborate to optimize resources, all aimed at reaching a level of spectrum monitoring that is future-proof. This proactive approach ensures that your system not only evolves but also adapts seamlessly to your specific requirements, keeping it at the cutting edge of technology and aligned with the latest regulatory practices. Our commitment to personalized service goes beyond software development. We offer comprehensive consultation services providing both technical and professional guidance to help you configure a complete monitoring system that meets your specific needs. We are excited to share our latest innovation, which we currently work on, the AI-assisted anomaly detection. Currently in preview, this feature uses unsupervised machine learning models to analyze measurement data and detect anomalies in broadcast bands. You can see here the key capabilities, including automatic detection of active broadcasts, identification of new potentially unauthorized transmissions, detection of unexpected broadcast station shutdowns, or recognition of significant bandwidth or channel profile changes. This AI-driven approach significantly enhances your ability to maintain spectrum integrity and respond quickly to potential violations. The AI model can be trained on reference data, allowing it to detect subtle changes in the spectrum that traditional monitoring methods might miss. This could include gradual profile increases in licensed transmissions, or intermittent unauthorized transmissions, or changes in modulation characteristics. In the future, we plan to extend this AI capability to other frequency bands and types of transmissions, further enhancing the automated monitoring capabilities of Simon International. Our experience has taught us that effective spectrum monitoring is not just about having an extensive feature set, but about implementing best practices that align with the regulatory needs. Simon International embodies this philosophy through a user-friendly web-based interface developed with UX research support, workflow that starts with an interactive map for intuitive navigation, direct access to all measurement functions across vendors from a single application. These design choices ensure that your team can work efficiently and adapt to new challenges without being hindered by technological limitations. Our system architecture is flexible and scalable. It consists of a central controller that manages multiple station controllers. This design allows for both centralized control and autonomous operation of individual stations when needed. In terms of network requirements, Simon International supports various connection types. In conclusion, Simon International provides a unique combination of vendor independence, customization potential, and cutting-edge features. By choosing our system, you are not just acquiring software, you are gaining a partner dedicated to evolving alongside your needs and enhancing your regulatory efforts. Because of this, our business model is designed to offer you maximum flexibility and value. We can offer a one-time license fee per station with unlimited number of users, with unlimited compatible equipment per station, and we can offer our maintenance service, which can guarantee all the new features. Thank you for your attention. We are now open for any questions you may have.
Thank you everybody for your attention. During the meeting we had some questions. I tried to answer them in the chat, but I would like to say a few words about them. Basically, when we start direct measurements and also automated measurements, in both cases, we record the measurement data, so the users can replay the measurement data anytime later on. So even if you didn't prepare to record it beforehand, everything is stored on the measurement station, and the user has the ability to replay it later. And of course, the user can also manage and delete the unwanted recordings so that they can free up space. Another question was regarding the amount of space required to store measurement data. And basically, it depends exclusively on the resolution, the capabilities of the measurement equipment, and also on the measurement time. I wrote in the chat an example. If you want a very high resolution information regarding the FM band, basically with a 6.25 kilohertz step, the recording, or 2-hour recording, takes around 50 gigabytes of data, but normal measurements with lower resolution, but with enough information to be useful, it is around 1 or 2 gigabytes per day. Basically, some of our customers are running measurements scheduled for a month, and around with their settings, amount of measurements takes around 60, 70 gigabytes of data. There was also information that a question regarding, is there an algorithm that distinguishes a real signal from crackles in the spectrum? Basically, as Gergő also mentioned, there are developments with our software to integrate new machine learning algorithms to be able to distinguish anomalies in the system. And these are currently in research phase, so I cannot show you new examples. But we are taking our development direction also in this direction, to be able to help the users to
to concentrate on the rare and highly important problems, so that the automated spectrum monitoring should be more easily achievable. There was also a question about the integration of the devices. So basically, if you have a measurement equipment which was not in our list of currently supported equipment, we have a team of dedicated developers who can integrate these new devices. Basically, the requirement is that we have to have access to a device for testing and for development, and also the device should have a proper integration documentation, so that the developers can integrate and create a new driver to integrate this device. These device types can be anything like measurement equipment, also antenna rotators, signal switchers, DVB-T analyzers, or any other signal analyzer. The important is that to have access to the proper documentation and also access to the device during the development. There was also a question regarding how much time does system deployment usually take. It of course, the answer is depends. Basically, when everything in the background is ready, the installation of the software takes minutes, but the configuration of the software, the testing of the integration with the devices, network requirements, firewall requirements, and so on. Basically, a simple deployment with a central server and let's say 5 station, it can take around 2 or 3 weeks to deploy and configure a system like this. Of course, if the infrastructure and everything is ready, then the amount of time can be shortened. But usually, in our experience, it takes a few weeks to deploy a complete system. If you have any questions, please feel free to ask, or you can send us also questions by mail, and we will try to answer them later.
Yes, thank you very much.
Thank you. Have a nice day.
Thank you. Bye.